Okay, I was just checking up on to see what Roger Penrose had on YouTube. Any new information? And he says he wants to live another 5 years at least to see the results of Yvette Fuentes' study of the gravitational collapse of quantum superposition to test out his theory on how gravity explains why the collapse of the wave function occurs. And um, he's been giving the same talk for the past like 5 years, but he did some recent interviews where he explained himself better. Um, and I did a blog post on that. So essentially, he's saying, his big problem with quantum physics is that you have the deterministic Schrodinger wave function, and then you convert it to a density matrices, and then he says the diagonal of the matrices gives you the probabilities, and then he calls that the double ontological cheat. And he says once you have those probabilities, then you can have the reduction of the superposition as the collapse of the wave function. And um he says the problem is that, I mean, the problem with this cheat, he doesn't really go into the details of this, but the off diagonal um time and frequency of the matrices is what is the noncommutativity that's is maintained as non-local, um, despite the collapse of the wave function. So in terms of non-commutativity, you never need any wave function. And this was Basil J. Haley's big point to Roger Penrose in 2021 at the ME Mind Matter Symposium. And so Penrose just did a new talk um, to this research group, this guy out of India that's been working on similar subjects. And so I finally realized why Penrose was not able to understand Basil J. Haley. And it's pretty fascinating because, um, Penrose ultimately, he is a relativistic physicist. And so he says that quantum reality is not foundational. And if you think about it, Professor Jean Brimond explains how Stephen Hawking did not understand Bell's inequality. And I don't think Penrose really understands Bell's inequality as well, but he does a fascinating explanation. He gave his same talk again, but he gave more details this time, where he's basically saying you have this quantum superposition, and then you just rely on gravity as the force required to separate into two different particles that are above the Planck mass. And um, once that separation occurs, that um, gives you the uncertainty relation. In other words, um, depending on the size of the particles, that will tell you, that changes the frequency. That's then inverse to um, the time that the particles remained in superposition. So the higher the frequency, um, then the longer the time that the superposition would occur. because a longer um you'd have a longer wavelength. This is where you get into the inverse frequencies. And so he didn't go into the mathematical details, but one of the questions brought up later was they called it a Newtonian Schrodinger formula that Penrose devised. And what Penrose was saying was that he's using the Newtonian method where because since you can't actually make the measurement without in the quantum superposition without destroying the superposition, so you have to retroactively do the mathematical calculation, assuming there's going to be an error, an inherent error involved, because you can't do a precise measurement, so you're doing an approximation, and this is a method that Newton first devised. And so there's definitely some mathematical trickery going on that Penrose is using, and then he says that the time is complex. Or he says it's a cubic time for the phase because you have to take into account the two different vacuums of space time for the two different particles. But he says what's going on is that you have this retroactive measurement, so that um, like if in quantum experiments with the superposition, they just use Alice and Bob. So he's saying that in fact, the relativistic reality is what is causal. So you end up with just one, or you end up with two particles that are separated, but it's dependent on the when the original particle collapses from the superposition. But he's saying that the separate particle can be measured first um, in terms of linear time, but it's actually being caused um, in the past of the superposition time, or it's vice versa. He's saying that it can happen either way. So he's saying it doesn't matter in the quantum reality. So you can have, either way they're going to be opposite. Because they're one half spin and they're entangled, so they'll always be opposite. But um, they can happen ahead of time. So he's saying the only way you can explain this is that there's a retrocausal um, signal from the future to the past light cone of the superposition particle. And so again, he's in that situation, he's saying that the quantum physics relies on complex numbers. So he keeps saying complex numbers, but in reality, the whole point of noncommutativity is that the phase is not complex because the quaternions are actually an asymmetric algebra. And so you can have a, a cubic phase that's non-commutative without it being a complex number, because the complex number assumes a symmetric space-time for a rest frame. And so it's a very subtle difference. But his point was like, well, if relativity is not primary as reality, then the quantum physics would completely mess up the whole relativistic reality. Now, um, and then he puts this in the context of cosmology, because he's like, well, um, in terms of the Big Bang, he realized that gravity is actually highly coherent due to asymmetric time, and that it starts out as very low entropy. It's negative entropy, and And so the it's it's the opposite of what the quantum physics would be in terms of the entropy. And it's there's a he's saying that you have this distinct dynamic between, you know, relativity and quantum physics, but that um, the two are always like interacting in this manner. And so in some of his talks, he relies on the de Broglie-Einstein relation to show this how you convert the mass of space-time back into quantum frequency. And um, the problem again is, as Basil J. Haley points out, is that de Broglie was actually wrong because de Broglie was still trying to rely on this Euclidean space-time, but because the time is inherently asymmetric, then it's not a Euclidean space-time. It's this um, noncommutative time and frequency. And so I think that's why, I mean, I know for a fact that's why Penrose literally just refused to engage with Basil J. Haley when Basil J. Haley was talking to Penrose and trying to get Penrose's feedback. And it was really frustrating to watch. And this happened, more than once to Basil J. Haley. And I think that had a deep effect on Basil J. Haley's, sort of like he's trying to develop his work. And what's ironic is that Penrose he wants to stay alive to see Yvette Fuentes' experimental results, but then Basil J. Haley was trying to get these results with Robert Flack and using mass. So in this latest talk, I link it in my blog post, but one of the Indian students in India asked about having a non-displacement quantum experiment and how that would affect his thought experiment. Um, and he basically responded, "Well, if you have any kind of quantum mass displacement, it's going to cause the collapse of the wave function." And when he said that, then I realized he doesn't understand the weak measurement experiments, because the whole point of the weak measurement experiments is you can maintain a non-displacement by changing a quantum action or variable that's a quantum number that's before space-time exists. So you're changing just the momentum as proportional to the frequency as inverse to time, with this negative time or whatever. Um, or you're changing the spin. And so, it's that made me realize that he's he's not really like I completely understand his critique of quantum physics and I'm totally sympathetic with it. And he even says that in terms of biology, it is possible to access this precognitive quantum reality. And he says that explains, precognition but and then he says like, that conscious thinking is actually the collapse of the wave function. That's this relativistic causality, where you have linear time again. And all of that completely makes sense, in terms of my experience with precognitive dreams and visions and telekinesis and all this other stuff. I could go on and on, psychometry, but anyway, non-local perception, and but but the fact is, and the other thing is like qigong master Fep Chow. She said that the future and the past, they coexist, at the same time, and that a lot of times when people schedule to get a healing from her, they actually end up get healing on the way to the clinic. Like when they're driving to the appointment, they already get healed, before they've even told her what needs to get healed. Now that actually makes sense in terms of what Roger Penrose is explaining. Um, they like destroy relativity. Well, um, he's ignoring the ecological crisis, and that's my big point. Is that well, I mean, he said elsewhere that he did not think that civilization was going to survive abrupt global warming, and he just made it in passing. And in his latest talk, he said that he cannot have a moralistic view of reality. He said, unfortunately, that evil has a disproportionate effect in society. And in my view, that is due to relativistic physics. It's due to this wrong commutative mathematics having this direct effect on the quantum reality. And so it's a pretty fascinating dynamic going on because that was actually the view of Basil J. Hiley and David Bohm. Also, they said that because of this wrong foundation of reality, you have the ecological crisis and social injustice, because David Bohm was a communist or whatever. And but anyway, yeah, so I feel satisfied now to finally understand why Roger Penrose like refused to engage with Basil J. Hiley and sort of blew him off. And Roger Penrose has admitted he does not understand non-commutative quantum algebra well enough, even though he co-authored a paper on it, and he does admit that that's the foundation of his cosmology and for the relation of quantum physics and relativity. So it's very fascinating that he admits it in cosmology, but he's not able to um, make that connection in terms of the quantum biology research that he's been doing. And I tried to contact him once, but I mean, you know, he's like 94 or 95, and there's no way to contact him directly anymore. And I'm not trying to, you know, like rain on his parade or whatever. I hope, I mean, the experiment he's waiting to see the results for, that's great. And I hope Robert Fleck is able to continue Basil J. Halley's experiments. Anyway, I feel kind of weird because I don't do science, I don't do mathematics. I just try to understand the concepts and in terms of quantum biology or whatever. And yeah, that's I put the links in my blog post on Roger Penrose's latest talks on YouTube, and just wanted to get this out here, just my commentary on it. And I don't know, I feel kind of weird because I was able to correspond with Basil J. Hiley, and he understood, like he seemed to appreciate what I was writing about, and in terms of non-commutativity, and I mean, it's a really unusual like viewpoint in science. And Penrose, he is forced to acknowledge the non-commutativity, but I think he has yet to really like engage with its meaning, whereas Basil J. Hiley was like, yeah, Alon Khan is correct. And so um Penrose is talking about von Neumann when Penrose was critiquing quantum physics. He said that von Neumann came up with the formula to convert from the Schrodinger equation into a density matrix for probabilities. And so Alon Khan, he gave this, really, like he did his PhD on this, where he analyzed the different types that von Neumann developed. There's like type 1 and type 2 and type 3. And it's the type 2 that's like the crucial type in non-commutativity, and that's what, Long Connie's given talks on that. And so this is what Basil J. Haley, he referred to that in detail. He's talking about the type 2 um, that Alon Khan talks about. So, but Penrose, he hasn't like taken a look at that at all, as far as I can tell. I mean, maybe he has, but he hasn't mentioned it. So, um, yeah. And anyway, yeah, I find it super super fascinating. 'Cause, um, but uh, well, we'll sign off and